In this lecture, we are going to cover superposition. So superposition is not really a equivalent circuit theorem. It is a method actually for circuit analysis. But since it's using the same techniques as we used in Thevenin's and Norton's equivalent circuit, so that's why I want to put it into this chapter to just follow the Thevenin's and Norton's equivalent circuit. We can give you some really similar examples within this chapter. Superposition. So let's look at this circuit first, and then I'm going to introduce the procedure to solve this circuit using superposition. V1 equals to 4 volts, R1 equals to 4 ohms, R2 is 4 ohms as well, and R3 is 2 ohms, and I1 is 1 amp. So here is a circuit, and we're trying to use a superposition method to solve every single voltage node and every branch current in this circuit. So the way to do that is you just take every single source, doesn't matter it's a voltage source or current source. You just use one of the sources first at one time and disconnect all the other current sources and short all the other voltage sources in the circuit. Just do it one by one. And eventually, you just superimpose all these values you calculated from every single source together to that component. So you can get the total effective current or voltage applying to every single component. All right. It seems like pretty complicated, but actually it's super simple. Let's follow the procedure and try to solve one example first. So here, since we have two sources, one voltage source, one current source, for example, let's just use V1 first. So we saw V1 only in the circuit. So we have to disconnect any contribution from this current source to the circuit. So the way to do that is disconnect the current source. If this is a voltage source, you need to short it. If it's a current source, you need to disconnect it. So only V1 there. Okay, so this is V1 equals to 4 volts, R1 is 4 ohms, and R2 is 4 ohms, and R3 is 2 ohms. So this guy is removed, so there's nothing over here. So in that case, there's no voltage flows through R3, no current. No voltage applied to R3 and no current flows through R3. So it's pretty simple because we can, if we define the polarity of these two guys like this, plus minus, then we can get, so for example, the voltage over here, we call it VR1. So VR1 equals to what? In this circuit. It's a voltage divider, right? So it's 4 volts. It's actually V1 times, we'll get the voltage over here. So it's 4 ohms over 4 plus 4. So it's actually just a half of 4 volts is 2 volts. That's VR1. So what is IR1? And we define IR1 like this. So IR1 equals to VR1 over R1, which is 2 volts over 4 ohms, which is 0.5 amps. So we are done with R1's voltage and current under V1's contribution. Okay, so what about R2? So R2 is like this. We define plus minus like this. And so this is VR1, VR2, and the current flow in that direction is IR2. So VR2 equals to V1 times 4 volts, 4 ohms, because it's 4 ohms as well, which is 2 volts. And IR2 is VR2 definitely over R2. It's 2 volts over 4 ohms, is also 0.5 amps for IR2. So this is the voltage and current um, with V1's contribution. So the second case, we should only leave I1 there, but short the other source, which is a voltage source, 4 volts voltage source. So I1 only. Then we are going to have this guy is shorted. So this one will be in the circuit, which is R3 I'm talking about. For doing a superposition, you just need to be really patient when you are solving a circuit using superposition. All right. So now we have 1, 2, 3 resistors in the circuit. And so we are trying to calculate the voltage and currents for every single component. So we can superimpose these values to the values we calculated over here, right? So still, keep in mind, the polarity is very important. And now, because the current is flowing in that direction, so it becomes, for R1, it becomes plus minus like this. All right, so VR1 in that direction will be something else. And you can tell that this is 1 amp going here and being split by 2 branches, and they have the same resistance. So actually, this is a very simple example. We know that it's going to be 0.5 amp for each branch. So VR1 will be 0.5 amp times 4 ohms in that direction, plus minus, which is 2 volts. And IR1 will be 1 amp, 0.5 amps, since it's given. It's pretty much given, and we can use a current divider to calculate it. So that's for R1. What about R2? R2 is still plus minus from top to bottom. So VR2 equals to 0.5 amps times 4 ohms, which is 2 volts, and IR2 is 0.5 amps. And for I3, it's plus minus like this in this direction, right to left, and we define the current like this. So VR3 equals to what? So how to calculate that VR3? Since we know the current flow through this guy is 1 amp, so it's going to be 1 amp times R3, which is 1 times 2, which is 2 volts. And IR3 in that direction is 1 amp. So now we get the current and voltages for R1, R2, R3 under the contribution from V1 and I1. So the very last step is just to superimpose these values together. If they have the same direction, then just add them together. If they have the opposite direction, you need to add a minus sign in the front. So let's make a summary over here. So in total, what is VR1? The first time you got a VR1 in this direction, and the second one you got a VR1 in the opposite direction, and they have the same value. So you can see it's being cancelled. So there's actually no voltage across R1, right? Because so the overall VR1 equals to, if we define plus minus R1 like this, is the overall directional polarity of R1 in the original circuit. And this is IR1's overall current direction. So you need to keep the VR1 from the V1's contribution as positive, and the I1's contribution as negative because it has an opposite polarity, right? So it's going to be 2 volts minus 2 volts, which is 0 volts. So in that case, IR1 overall will be VR1 over R1, which is 0 amp. So it's actually, there's nothing flowing through R1. So what about R2? Since R2, for the two cases, they both have a top to bottom as plus minus. So they should be added together. So VR2 equals to the first one, we got 2 volts. And the second one, we have 2 volts. So VR2 is actually 2 volts plus 2 volts, which is 4 volts. IR2 will be VR2 over R2, which is 4 volts over 4 ohms, which is 1 amp. Which makes sense because there's no current flow through here. You got 1 amp and nothing here, so it's going to be 1 amp from top to bottom over this resistor. And R3, since there's no contribution from V1 for R3, so we can directly just use whatever being calculated from I1 for I3. And doesn't matter which direction you want to define. I mean, the final, let's just copy over, make things easier. So VR3 is 2 volts, IR3 is 1 amp. So that will be the final result for this circuit to be solved and using the superposition method. Okay, I'm going to cover more examples in the following lectures, and hopefully you can get it later. Okay, I'm going to see you in the next video.